I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 2nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see a gale pushing south and of no real interest, no energy aimed off to the north, and a far weaker system over the central South Pacific, trying to push northeast, but pretty weak and not offering a whole lot. Other than that, pretty quiet pattern is in control. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they develop, help direct their track. We're looking for a trough, and in the southern hemisphere, that would be winds pushing to the northeast, just like right there. So what you end up getting is a clockwise flow, and that is the hallmark of low pressure in the upper atmosphere and also down at the surface. If the low pressure is strong enough or deep enough, it generates winds. If the winds are strong enough and aimed in your direction, they generate seas. And of course, those seas, as they radiate away from the fetch area, eventually turn into swell. And when that swell hits your beach, it turns into surf. All right, so we have we'll call it a pretty weak trough right here. Winds, 100, maybe 110 knots trying to feed up into it. And we know there's some sort of weak weather system here being supported by that upper level flow. More of the same continues as we get into Monday. The trough, maybe not even as steep, and then it slowly starts fading out on Tuesday over the southeast Pacific, while winds build again under New Zealand at about 140 knots, not really forming a trough, but maybe offering a little bit of area to support low pressure development. And then as you get further into Wednesday night and Thursday, a legitimate trough actually starts developing with 150 knot winds flowing up into it, offering support for gale development again over the central South Pacific, continuing and holding pretty stable. Actually, the trough looking good as we get into Friday night and even into Saturday, looking better with a broad area of 130, almost 140 knot winds, filling pretty much the South Pacific Ocean, and then the trough starting to get a little bit pinched, not allowing a good upper level circulation there as we get into Sunday, and then it pretty much gets cut off with wind pushing down into Antarctica, and that's pretty much the end of it. All right, let's go take a look and see what effect the upper level winds will have down at lower in the atmosphere. So here we go, surface level pressure, surface level winds. We know there's a trough in this area, nothing special. And at the surface, we have a low pressure system. Was that a 968 millibar low with 30, maybe 35 knot winds pushing off to the north? You're not going to get 30 or 35 knot winds. You get maybe, 20 foot seas, 22 foot seas, and a 12 or 13 second period. So as we get into Monday, a new little low starts to coalesce out of that, maybe 45 knot winds over a tiny area, continuing building actually in coverage as we get into Monday night, and also some fetch way further north, but still only 30 knots. And then into Tuesday, another it's sort of a broken up pattern here. All this fetch aimed off to the south. There's some fetch aimed to the north here, and here. And then we know as we get into Wednesday, something new potentially, and there we go, as we get into even before Wednesday, something new starting to form under New Zealand as that low fades out. Winds 45 knots, pushing off sort of to the northeast, new low, but this is outside of the California swell window. Southern California about 118 west right there, and most of this fetch looks like it's aimed at Peru and Chile. So this guy here and this one here, and also notice, this is kind of what you want. High pressure over New Zealand, flowing, actually it would flow counterclockwise. Low pressure to the southeast, flowing clockwise. You get a gradient between the two of them, and then you get northeast fetch. Now, we're not saying that's what's I mean, it's sort of happening here, but not like really supercharged like what you'd want to see. But still, 35 knot winds. That's good for swell into Tahiti, maybe into Hawaii. Low pressure continuing over the southeast Pacific. So we get into Friday. Now we know there's a big trough supposed to be building here. So let's see if anything materializes. And there we go, 40, 45 knot winds as we get into Saturday night, Sunday. Oh, and a broad new low pressure system also forecast. What, 50 knot? That's a storm as we get into Monday in the South Pacific Ocean. So the GFS model hyping things up pretty good about a week from now. We'll see what happens as we get 3 to 4 days out from that and see if any of this materializes at all. So let's see what effect the winds have on the ocean surface. We're actually going back to Friday evening, just 2 days ago. Little low pushed under New Zealand, 30 knot winds, and 30-foot seas falling to 29 feet as we got into Saturday. And then, that gets us to where we are right now, this sort of, weak low pressure system, and that guy we're not even talking about. So let's go look at the forecast now. Here we are, moving forward. This low, we know we saw winds building on it, 29-foot seas as we get to Monday evening, 32-foot seas, and that's about it. It kind of fades out. We know there's another low pushing under New Zealand as we get into Wednesday, 32, maybe 34-foot seas. That too kind of fades out. This low is out of the picture, but sort of a broad area of, we'll call it disturbed weather as we get into Wednesday and Thursday. I mean, so we've been having the same sort of situation right now where there's just this steady background swell in the 1.7 to 2 foot at 15 to 16 second range. And this looks like a continuation of that kind of pattern where just, rideable surf, nothing great, but something. And then a deeper little low supposedly building Friday, sort of more of a primer low, 30, 32-foot seas aimed off to the northeast. Then we know a stronger pattern is to be setting up behind that. This model only goes out 180 hours, but we would expect if all the stuff verifies, a week from now that maybe a broader area of seas would start building down here, but that's a long ways away. Just for fun, we'll take a look in the North Pacific Ocean. We're just blasting through this because there is literally nothing. I mean, we're looking for, there is a low forecast here in the Gulf, but not even 18-foot seas. And without that, it's nothing really interesting. It's just weak wind swell. And we'll get into that in a minute. So basically, nothing for the North Pacific. And then a quick look at wind swell production. High pressure in control was at a 1030 millibar high, driving north winds along the California coast. It's a ragged, ugly mess today over North and Central California waters. 25 knot northwest winds blowing. Trades pushing on into the east shore of the Hawaiian Islands, 15 knots, probably generating some sort of short period wind swells. We get into Monday, winds only build more as the high pushes closer to the coast. 30 knots over northern California waters, but maybe a little bit calmer down into central California. Still, much wind swell production. Fetch fades out pretty much relative to Hawaii. Tuesday, more of the same, though. The gradient starts fading. We see there's some low pressure forecast here off the Pacific Northwest. So this shows 30, 35 knot northwest winds. So maybe there'll be some more westerly wind swell for California, and high pressure building right behind that at 1030 millibars. Trades for Hawaii. So we get into Wednesday night and into Thursday. A brief break in the wind machine for California, but then we get into Friday, and here we go again. This looks like a repeat of where we were when we were just starting. 1030 millibar, 15 knot to 20 knot trades pushing to the Hawaiian Islands. 20, 25 knot plus winds raking the northern California coast. We're into Saturday, more of the same. Big, raw wind swell and northwest winds. Oh, and look at that. And a broad, pretty well-developed fetch of 20 knot winds pushing from off the California coast the whole way to the Hawaiian Islands. What's that, 1,000 or 1,500 nautical miles of fetch? So certainly some easterly wind swell. And we continue out into Sunday, pretty much more of the same. So wind swell, the name of the game for sure for California and Hawaii. Small southern hemiswell, it looks like, at the most protected south-facing breaks, mainly focused on California, but maybe some tiny energy for Hawaii. For laughs, we're looking for rain for California. We're just going to blast through this because the short of it, there is really nothing forecast other than the low. Forecast off the Pacific Northwest will bring some showers, we'll say, to the Cape Mendocino area on Thursday, and this is actually looking even weaker than it was yesterday's runs of the model, so even any rainfall into California looks highly debatable at this point in time. And that is it. We're out 180 hours, high pressure in control. We're not even going to talk about snow because there's no snow in the forecast. All the major resorts have shut down other than Squaw, and all the lower mountain is closed. KT got its last runs in, I think it was on Friday, Saturday, and Headwall's down. It's Granite Chief and Shirley Lake, and that's pretty, and some of the green stuff up top, and that's it. And I'm sure with temperatures rising, things won't last very long, so get what you can while it's there. Otherwise, we're waiting till the winter. All right, so let's go take a look long term. What's going on with the Madden-Julian Oscillation? And thank goodness it is alive again. And the El Nino Southern Oscillation. Big changes underway. As usual, we start looking at winds over the equatorial Pacific. Everything is about the area from 5 degrees north of the equator to 5 degrees south of the equator and different areas. So this is the East Pacific, this is the West Pacific. In the Far East Pacific, you have the Nino 1.2 region. And what you're looking for there is water temperatures. It's very noisy, but if you see warming in that area, that can be a good sign. The official El Nino monitoring region is the Nino 3.4 region, from 120 west out to 150 west. Again, 5 degrees north and south of the equator. You look for water temperatures there. If they're warmer than normal, then that's maybe a trend towards El Nino. Has to be half a degree above normal for 5 consecutive 3-month periods. Or if it's half degree below normal, then perhaps you're in La Nina, and of course, that's not good for surf production or rainfall into California. Then beyond that, from 170 west the whole way over to the far west Pacific, 5 degrees north and south of the equator, we monitor wind direction and speed. Normally it's trades in this area out of the east. But when the active phase of the MJO moves over this area, it can take trades, reverse them, and take warm water that's here, start pushing it to the east. Not on the equator, but under the equator, 150 meters down. So what's that, about 450 feet down? Takes warm water, a ball of warm water, pushes it the whole way across the Pacific. It can erupt along the coast of Ecuador and the Galapagos, gurgle to the surface, and then start warming temperatures in the Nino 1.2 region, and then the trades will take that warm water, pull it into the Nino 3.4 region, and then you start the machine with Kelvin waves in active phase of the MJO here, pushing warm water off to the east, warming temperatures over this whole region, which then changes the jet stream pattern, creates more evaporation, and then you're in the swell. The swell production machine really starts off in that sort of a scenario. We're not there at the moment, but that's what we're looking for. So right now, wind's pretty strong out of the east over the east equatorial Pacific. We're just looking at the arrows. Moderately strong over the central Pacific, and moderately strong in part of the Kelvin wave generation area, but fading and almost turning westerly in the far west Kelvin wave generation area. But it's not the actual wind speeds, it's the anomalies. Differences from normal for this time of year. And you see, yeah, the trades are pretty strong, but looking at the arrows, there's no real east to west component to them, so that's pretty much normal. Central Pacific, pretty much normal. But in the Kelvin wave generation area, winds are actually out of the west, which means possibly the active phase of the MJO is here, and possibly that can help generate a Kelvin wave, and that's exactly what we want. So what's the forecast for the next week, all right? Most of you understand this chart, but we'll do it anyway. This is the whole planet on one chart. The date line runs right up the middle. The zero meridian runs right over here. That would be like England. So the Pacific starts at about 135 east, and this is the Kelvin wave generation area we're really interested in. That's where these winds have the big impact. So from 135 east, the whole way up the chart, to 170 west, so right about here. So in your mind's eye, just look in this box right here. The yellows and oranges are westerly anomalies, indications of the active phase of the MJO. You can see the active, now there was a computer outage here, but you can see the west anomalies since the beginning of April have been traversing through the Kelvin wave generation area. They have 1, 2, 3, maybe 4 more days left. And then easterly anomalies start building in the Kelvin wave generation area. So this suggests the active phase of the MJO here, and you can see it literally moving off to the east. It doesn't do it like in a perfectly straight line. It kind of goes and fits and starts, and that's what it's showing here. But then here comes the inactive phase of the MJO, and this is pretty typical. About 4 to 5 weeks of the active phase of the MJO over the Pacific, moving from west to east. And then comes the inactive phase for 4 to 5 weeks, moving from the west to the east with the blue, the easterly anomalies. That is not favorable for feeding energy to the jet stream and not favorable for storm production. Let's go look out a little bit further. Outgoing long-wave radiation. So there's multiple components of the MJO because the MJO is basically like the active phase is like a low-pressure system that moves from west to east around the planet on the equator. The inactive phase is like a high-pressure system that moves from west to east. The inactive phase, because it's low pressure, produces clouds. Outgoing long-wave radiation is a fancy words for cloud cover. Where you have the blues is you have a lot of cloudiness. So this is the statistic model, 4 different panels today, 5 days from now, 10 days from now, 15 days from now. And there is the equator right there, EQ. 180, that's the date line. There's South America, Central America, Hawaii, Australia, New Guinea, the Philippines. You get it. Kelvin wave generation area. This is what we're interested in. On the equator, 5 degrees north and south. So from here, a little box right in your mind's eye right there. The reds indicate lots of sunlight reflectivity, lots of outgoing long-wave radiation bouncing off the ocean surface. That means no clouds to obscure that sunlight. That means high pressure. That means the inactive phase of the MJO. And this is the statistic model. So you can see it pretty clearly here. Inactive phase building over the Kelvin wave generation area for the next 10 days, then starting to fade while a massive, strong, active phase of the MJO builds over the Indian Ocean. Let's see what the dynamic model says. Now, this is a little bit different. The dynamic model says the inactive phase hanging out for a day or two and then just completely collapsing, but also the active phase completely collapsing too. And we just move to complete neutralness 2 weeks from now. Big difference between the statistic model and the dynamic model. So the point being, we never get our data from one source. You look at multiple sources, you compare and contrast them, and try to find either a common thread or try to understand why one model is, telling you one story and another model is telling you a different story, and the two stories don't intersect. All right, what are we looking at here? So this is the phase diagram chart. This is the statistic model. This is the dynamic model. The MJO, the active phase of the MJO, moves from west to east, from the Indian Ocean, over the maritime continent, to the West Pacific, East Pacific, over or underneath the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The dot here, right there, you can't see it very well, is where the active phase is today. So we'll say it's over North Africa. And the further it is away from this circle, the stronger it is. So a very strong active phase of the MJO over North Africa, getting ready to move into the Indian Ocean today. And over the next 2 weeks, the statistic model has 3 different outcomes. Either it moving to the central Indian Ocean and being exceedingly weak and all but collapsing, or staying extremely strong and making it to the East Indian Ocean. The dynamic model says, it says sort of the middle line here, right? It says the active phase starting to collapse in the central Indian Ocean, making it to the maritime continent exceedingly weak 2 weeks from now. So vastly different stories between these two models. The reality is probably somewhere in the middle. Next up, the upper level model, and this talks about the wetness component of the active or inactive phase of the MJO. The oranges are dry air, typically associated with the inactive phase. The greens are wet air associated with the active phase of the MJO. And wet air also gives you cloudiness, so you sort of get the idea here. Low pressure, wet air, cloudiness, or inactive phase, dry air, clear skies, and no precipitation. All right, so there's 8 different panels here. Each of them is about 5 days apart, I think it was. I'm just trying to eyeball it here. And right, 40-day model. All right, so here is South America, Central America, the equator, 0 degrees right there. There's the Galapagos. You even can see it, 1 pixel. And New Guinea, the Philippines, Kelvin wave generation area right in here. So, and this runs about 5 days ahead of what's going on at the surface. So dry air already in control of the Kelvin wave generation area. Inactive phase of the MJO, making its trek presumably pretty quick across the Pacific, pushing into Ecuador. That'd be right in here, somewhere about the 22nd of May, so 3 weeks from now. At the same time, the active phase of the MJO is forecast building over the Kelvin wave generation area and making its trek across the Pacific and into Ecuador by about June 11th. And at that time, a new inactive phase starts building. So inactive phase, active phase, inactive phase. You can see the periodicity on this, and it's just when things are going right, the active and inactive pattern is real obvious. When you have El Nino, what you end up with is basically a long-running active phase of the MJO. When you have La Nina, you have a long-running inactive phase of the MJO, or strong inactive phases and weak active phases, with, the inactive phase being dominant. And then, of course, the flip side in El Nino, long-running active phases with tiny little inactive phases. All right, let's go out a month looking at the surface. This is the CFS model. Again, whole planet one chart, date line right there. West Pacific, about 135 east, so right there, to 170 west is the Kelvin wave generation area. And California is down 120 west right there. And Ecuador is about 80 west, somewhere right there. All right, so you can see here pretty clearly the solid contour is the active phase of the MJO. Now, this is all in the past. The whole month of April was moving from the Indian Ocean over the Kelvin wave generation area, i.e. the West Pacific, with the reds, the west anomalies, and now it's making its track over the East Pacific and towards the Atlantic and heading off out of our area of interest. The dotted contour is the inactive phase of the MJO. You can see it, here's today, just now starting to make some sort of a toe in the door in the Kelvin wave generation area. Forecast to continue to about May 20th. That's what we saw in the other models. But notice, when it's really over the Kelvin wave generation area, it doesn't do a whole lot. Yeah, there's some east anomalies, a little bit of west anomalies, but it's not till it hits about the date line that it kind of wakes up and does something. And why is that? Well, we'll talk about that in a minute. We talk about high and low pressure biases and things that are driving the trend towards El Nino or La Nina. We've been in a high pressure bias in the Pacific all last winter, last fall, which favors La Nina. That is moving out. And so even though the inactive phase is moving in, we think a low pressure bias is starting to set up here. And what that does, it basically blunts or takes the energy out of the inactive phase. But then when the active phase moves over like here, it's low pressure and the low pressure bias there. So it like doubles down on the low pressure bias, feeds it, and then stomps or negates the inactive phases. And of course, the reverse is true during La Nina. So we're moving from an unfavorable La Nina climate to a favorable El Nino climate. That's not saying that we're getting El Nino, but it feels like we're moving in that direction. And then, of course, you can see here, as we get towards the end of May, the active phase of the MJO starts developing. Not in the Kelvin wave generation area yet, but look at that. Westerly anomaly starting to set up well before it even reaches the Kelvin wave generation area, if you believe a model a month out. All right, let's keep going. And then finally, the 3-month CFS model. Now the future's up here, and the past is down here. Kelvin wave generation area, well, there's the date line right there. They're running the whole way up the chart. And the interesting part here is, here's the date line, blue anomalies. They're all like filling the Kelvin wave generation area. But as soon as you get within the next couple of days, well, there's the date line right there. Notice the blue easterly anomalies are all east of the date line. And the Kelvin wave generation area, which had only easterly anomalies all winter, all of a sudden you see westerly anomalies starting to build in it. All signs of the active phase of the MJO, all suggesting a return to a normal ENSO pattern instead of La Nina, at least not El Nino maybe, but ENSO neutral. All right, so let's overlay the MJO right here. Here we go. Right, so here the solid contour is our active phase of the MJO. It's all but gone today. Here comes the inactive phase of the MJO, this dotted contour. But even as it develops, notice you have pockets of westerly anomalies in the Kelvin wave generation area. Not much. We're kind of reaching at straws here. But not strong easterly anomalies either. They do develop. But again, it's all at the date line and east of the date line, filling the eastern Pacific, which will do nothing but feed that persistent high-pressure ridge that's been sitting over Alaska. They talk about the ridiculously resilient ridge, and that discussion will probably pop up this fall about, gosh, the high pressure just won't leave the Gulf of Alaska. That will probably be the case until the low-pressure bias moves a little bit further east and nudges the high-pressure bias out of the way. All right, but anyway, then the active phase of the MJO, a pretty strong one, forecast setting up, in the Kelvin wave generation area, late May, continuing the whole way through, well, let's see, the date line, we'll call that the far east side, so till about July 21st. So if there was a window for storm production, we would say it would be pretty much the whole month of June into late July. Then even after that, the inactive phase sets up, but notice, westerly anomalies still in control, and all easterly anomalies east of the date line after that. So that's moving us in a good place. All right, so what's really driving this? Low pressure, the low pass filter, the high pressure, low pressure bias. So dotted contour is the high pressure bias set up over the entire Kelvin wave generation area. But notice, it's moved from 4 contours, 3 contours, that'll be gone in a day or two, down to 2 contours, and that'll be gone by June 11th, and 1 contour, notice it just starts shrinking in coverage and moving off to the east to a point where its western periphery is just a little bit off the California coast, and most of it is inland over the southwest U.S. as we get into late July. And this is the part that's really fun to look at. The solid contour is the low pressure bias. We want low pressure, and we want it over the Pacific. Well, notice, see that little pump? It's like it's starting to nudge off and starting to push the high pressure bias out. And as we look at this collapse here of the high pressure bias and the low pressure bias moving into the Pacific, as we get into, well, there's the date line. We'll just eyeball it right around July 13th, something like that, the low pressure bias starts filling the Kelvin wave generation area in sync with this active phase of the MJO. It's not a coincidence that these two are happening at the same time. The active phase of the MJO is nudging the low pressure bias. The low pressure bias is feeding the active phase of the MJO, pushing the high pressure bias out of the way and setting us up for perhaps a normal fall long term. All right, enough of the MJO. Let's go talk what's going on in the ocean, because there is a subsurface, a down in the ocean component to all this, to El Nino, La Nina. There is a ocean surface temperature component, and then there's the effect of what's going on in the ocean and this low and high pressure bias with the atmosphere. And the ocean and the atmosphere interact together when they're coupled, then you get either La Nina or El Nino. Right now, we're saying they're not coupled, in that the atmosphere is still thinking to a certain degree we're in La Nina, but the ocean is thinking, we're not anywhere near La Nina anymore. We're not in El Nino, but we're at least in a neutral state, okay? So this is data from the TAO buoy arrays, series of buoys strung across the equator used for monitoring El Nino. These X's are sensors on the anchor lines of the buoys, anchored in exceedingly deep water. The sensors collect data. It gets beamed up to satellite and then down to a central processing facility. They apply a model to it, and you get sort of an average look at what the subsurface ocean temperatures are. The 28 degree isotherm, 28 degrees centigrade, which is pretty warm water, was back at 165 east all winter long. You see, I mean, even last week when we looked at this, I think we were at 171 west. Now we're at 165 west. So warm water on the move to the east. That's exactly what we want to see, because warm water supports evaporation. Evaporation supports low pressure, and we want low pressure in the Pacific. Whether it's the winter or the summer, low pressure in the equatorial Pacific feeds the jet stream in either way, and that, of course, generates swell. All right, and the 24 degree isotherm, which never made it past 140 west this winter, is nice and deep. What is that, 110 meters? Let's say 100 meters deep at 140 west, pushing the whole way into Ecuador. Exactly what we want to see. But it's not the actual water temperatures. It's the differences from normal for this time of year. Again, anomalies. You see 3 degree anomalies, positive 3 degree anomalies, in the far west Pacific and bulging off to the east. This is a new Kelvin wave pushing from west to east, and there is already a Kelvin wave in flight, 2 degree above normal anomalies pushing into Ecuador in that region. There are a little pocket of negative anomalies here, but that is not at all anything. This whole winter, this was all full of just iceberg cold water. That's all gone now. This is a good sign. It suggests a return to ENSO neutral. And here's another model that shows the same thing. Kelvin wave number 1 now starting to push, just with the 28th of April update, starting to tickle the surface here a little bit, starting to push into Ecuador's right about 80 west right there, pushing into Ecuador. Last little bit of cold water, probably getting squeezed out around Peru. And then there is this new Kelvin wave from the active phase of the MJO that just got through happening, started to make its trek across the Pacific. It'll take it about 2.5 to 3 months to make it into here. So we're right on the cusp of a subsurface, well, the subsurface change has happened, but it hasn't manifested at the surface yet, but we're right on the cusp of that. Sea surface height anomalies, all right? So that's South America there, Central America, Mexico. Where's Hawaii? It's right there, hiding right there. This is the equator. This is the date line. Right there is Ecuador and Australia. Kind of a funky looking chart, but it's a chart just the same. And what it's showing is plus 5 centimeters anomaly. The ocean is 5 centimeters higher than normal there, and normal or higher than normal almost the whole way across the equatorial Pacific. All winter long it has been below normal. You can still see the lingering end of a big triangle here of what was cold water, strong trades and depressed ocean heights because of strong east anomalies, and cold water at subsurface contracts and it creates a little divot on the ocean surface. We don't see any signs of that anymore. So it appears we are in the transition where La Nina is dead, Kelvin waves are in flight, water temperatures we think are on the rise, certainly subsurface wise. We haven't seen it at the surface yet, but we'll find out in a minute or two. And that would certainly be the demise of La Nina. And another view, upper ocean heat anomalies. All right, so this is the East Pacific here, West Pacific here. The blues are below normal temperatures. You can see one little Kelvin wave last summer in July, very weak didn't even make it to Ecuador, died out. Cold water was in control from April the whole way into November. Just scroll down here, and then all of a sudden, a massive retreat of cold water as warm water, you see it building up here in the west, east anomalies, just pushing, scraping every bit of warm water in the Pacific into the far west Pacific. As soon as the trades backed off and gave way, boom, east, the warm water started moving off to the east. It's currently at 95 west, so just off Ecuador is at 80 west. And then you can see now the second Kelvin wave starting to build and make its way across the Pacific. So a much better pattern, surf production-wise and precipitation-wise, is trying to organize. Now, it's not going to happen like that. It's going to take months, probably 6 months or more, for this to start having effect. This is water temperatures in the ocean, right? To really start having a significant effect on the jet stream level and the upper atmospheric circulation, because it has to do it the whole. It has to change the whole way around the planet. So this pattern needs to set up. It needs to be stable there for a while. For then every other component of the atmosphere to go, oh, hey, look, something's changed in the ocean. Let's reconfigure ourselves. But we are at the bleeding, hairy edge start of what appears to be a better pattern. All right, sea surface temperature anomalies. So we've said, oh, what are we looking at here? There's Chile, Peru, South America. Ecuador is right about there. There's the Galapagos. Central America, Baja, Mexico, Hawaii. The equator at 0 degrees, so roughly right there. Okay? And we see cold water upwelling off of Peru, but significantly smaller in coverage than it was last week and not as cold. We see pockets of warm water trying to build, very weak here, but the whole way across the equator out to the date line now, but with cooler water all south of it. But north of there, here's the other view here, it's pretty much all warm water except for this outflow here off of California, being driven by that bulletproof, ridiculously resilient wedge, high pressure, whatever you want to call it, sitting right here, driving those north winds along the California coast, the upwelling, the cold water temperatures, and that continues the whole way out just south of Hawaii. Hawaii is protected, still in a warm bubble, in the center of the high where winds are nice and light. But as warm water from those Kelvin waves builds here, the idea is that should start evaporation going here, which then should start taking the edge out of the high pressure and start reducing the strength of the high, and then these temperatures will start warming. Oh please let the water temperatures warm up in California, north of Point Conception. Right now, though, no clear, obvious signs. We know a Kelvin wave is trying to hit somewhere in this area and gurgle to the surface, but we're not, at least according to this chart, we're not there yet, but any day now we're expecting to see something. This is the chart we're really watching, sea surface temperature trend for the past 7 days. We'd expect to see, like that kind of red or that kind of red or that kind of red starting to show up somewhere right in here when that Kelvin wave finally really starts breaching the surface and then warming up this area right in here. The more that happens, the better. But right now, it's still not right there. Remember that those subsurface temperature charts, those were models. You don't have enough sensors. There's not enough data to know exactly what's happening to the day. But we know those Kelvin waves are poised to erupt in here. The good news is we're not seeing any, no cooling along Peru, no real cooling in this area. It's just kind of a neutral pattern. We're waiting for the Kelvin wave. Kelvin wave number 1. And we know there's a second Kelvin wave behind that too. And then, here we go. Again, the backed off view. You can see the upwelling pattern driven by high pressure off of California. There's pretty much the same thing going on here. High pressure in the Southern Ocean doing the same thing off of Chile. We need warm water, and you can see the faint signs of it all along here. We need those Kelvin waves to start erupting to the surface, warming here. That'll start breaking down the highs, start breaking down the trades, and then we'll be in a better position. But the reality is it's going to be a couple of months still. Sea surface temperature trend in the Nino 1.2 region, that area right there by the Galapagos, Ecuador. You can see we had a little bit of spike here in March. Temperatures dropped down. The La Nina indicator is a ½ degree below normal, so we're still in that sort of cool La Nina period. Today's value, 0.534, 534 thousandths of a degree below normal. So right on the threshold, we need to be above a ½ degree below normal, and certainly not for a day, but for months, before you can officially declare La Nina is dead. So you see there's this lagging sort of pattern going on. Even though clearly something's changing in the ocean, at depth, at the surface, it has not materialized yet. We know it's going to. And then after it materializes there, then it has to materialize in the atmosphere. All right, the Nino 3.4 region, the official El Nino monitoring region, we saw light warming in that area. Today, we're at dead neutral, minus 0.003, 3 thousandths of a degree below normal. We want to see this nudge above that line and then hold there for months. But we've been on the cusp of it since March. I mean, we haven't even been in the La Nina, the ½ degree below normal region since March 7th. So we're on the right trend. We just need more of it. All right, so what does the ocean think is going on? We use the Southern Oscillation Index. Remember, subsurface temperatures affect surface temperatures in the ocean, which affect the atmosphere above the ocean. All right, so the difference in pressure between Darwin, which is over, we'll say the Indian Ocean roughly, and Tahiti, which is in the West Pacific. When there's lower pressure over Tahiti for a prolonged period of time, the index goes negative, and that's what we want to see. Today, minus 20.28, minus 14 yesterday. Now 3 days here, you can see in minus 5.84. 3 days is not a trend, but it's a suggestion that maybe we're starting to move in the right direction. We've seen pockets of negative anomalies, pockets of positive anomalies. Are they balanced out? The 30-day average takes some of the noise out of there, minus 0.08. So pretty much dead neutral. And we just look for the past month. We've been at dead neutral for a month now. That's a good sign. So that's saying that, well, the inactive phase of the MJOs and the active phase of the MJOs over the West Pacific are pretty much balancing each other out. We're at equilibrium. We're at neutral. Okay, the inactive phase is not stronger than the active phase, and the active phase is stronger than the inactive phase. And then the long-term outlook, the El Nino La Nina index, 90-day average, plus 3.13, but you see where we've come from. We were at plus 7.88 a month ago. We were up to, I think it was 0.15 above neutral back in January. Now we're down to 3. So we're all, statistically speaking, we're dead neutral now, suggesting the end of La Nina. Let's go take a look at a quick graph. And this sort of bears it out. This is the 30-day moving Southern Oscillation Index. Today, here's where we are, hovering right about 0. There's neutral. Here is our La Nina, where we were for the whole winter. And then you can see back, well, we'll just go back, 2019, we were in a borderline El Nino, negative numbers. And then somewhere in about April of 2020, we started moving up and up and up and up. And now this is like a long-running active phase of the MJO, and we're just hovering at neutral right now. We want to see this actually push down negative. I don't know that that's going to happen, but at least we're not up here, which is good for getting rid of La Nina. And then finally, the sea surface temperature forecast from the CFS version 2 model. All right, so we're a little bit past the end of April into early May. Temperatures hovering about ½ degree below normal according to this, and the model suggests that slowly, ever so slowly, we're going to get close to neutral, say 0.2 of a degree below neutral in maybe mid-August, something like that. Then according to this model, falling back just right above borderline La Nina territory. Now, we're in the spring unpredictability barrier. It runs till about the end of the month. This model, as all the other models suggest, have a hard time during this barrier during the springtime. They're just not sure where El Nino, La Nina is going, that sort of thing. So we'll give this a pass for right now. We suspect this is biased on the low side, and all the other models seem to indicate we're going to hover just somewhere right around neutral as we get into fall and winter. So no El Nino coming. But theoretically, even this, the most negative of all the models, suggests no La Nina either. That's good news. So for right now, not a whole lot going on. It's this steady dribble of small southern hemiswell mixed in with significant northwest wind swell. That pattern looks to hold for the week. But if you can get to a good protected south-facing break, you can get some of the southern hemiswell and hopefully not too much of the north swell wraps in. Southern California, probably a lot better set up than Northern California for that sort of thing. But still, there will be surf. It's better than dead flat. That's okay. Water temperatures still supposed to be cold in California. Two significant upwelling events look like they're going to be happening this week. So just try to bear with it. The good news is long-term, 2 Kelvin waves in flight. Another active phase of the MJO forecast as we get towards the end of May, which maybe will set us up with a 3rd Kelvin wave. That at least should kick La Nina out of here. Are we moving to El Nino? Probably not for this winter, no. But at least ENSO neutral, that's okay. And as we get into, we're thinking around the Thanksgiving time frame, it's probably going to be a pretty slow start to the fall season because remember we talked about it takes a while for the atmosphere to change once the ocean starts changing under it. That's probably going to be the case. But somewhere around Thanksgiving, the atmosphere will probably figure out what's going on. It will reconfigure itself, and then hopefully we'll, on a 1 to 10 scale, we'll end up with a 5 winter, something like that. Fall probably be below normal though, but at least winter. And precipitation-wise, hopefully we'll do okay. We'll see how far the low pressure bias makes it into the East Pacific. All right, so if you enjoyed the video, give us a thumbs up. There you go. And comments are always welcome. We try to respond. Sometimes we get some pretty good conversations on arcane weather events and connections and things like that. So if you have a question or comment, please make it. It's good for the algorithms too. Also, if you haven't subscribed, please do subscribe. If not, go to stormsurf.com. That's where we post a link to the videos every week, the top of every page of the site. You can click it there and you can watch the video. All right. Thank you for watching. We'll do this again next week. Same time, same channel. Go surfing and stay safe. Thanks.